All right, we're going to present to you a new project within the Open vSwitch code base that started around January this year called OVN, the Open Virtual Network for Open vSwitch. I'm Ben Pfaff, and this is Justin Pettit and Russell Bryant, and we've all been involved in developing OVN over the last several months. So the origin story, or the reason for OVN, comes from the problem of network virtualization, and let me say a few words about what the goal there is. So often people are taking these legacy physical networks where you might have a set of switches, you might have a set of routers, and they're taking all of the machines in those and turning them into virtual machines on hypervisors. Now, when you put them onto a hypervisor, you find that you can't maintain the same physical network topologies because the machines simply aren't maintained in the same physical way. So if you want to be able to have the same structure to your logical network, then you need some software to provide that in some sort of an artificial way. And OVN does that. It allows your logical network to have the same features and the same logical topologies as your physical network. So beyond that, in networks, physical networks today, the end users typically don't have access to the ability to change the structure, to create their own networks. But when you get to logical networks and your virtual machines, you don't want to be talking to a network administrator whenever you need something new. So OVN also provides the ability to give self-service to the tenants of the logical networks. So why did we start OVN? Well, so there are lots of projects that try to do similar things, but we found ourselves unsatisfied with them for various reasons. We have collectively a lot of experience in building things in OVS that is unique, we believe, within the industry. Also, it seems like a natural evolution of the Open vSwitch project. Open vSwitch has always provided the components needed to build a distributed switch, but it had never shown a way to put all those together, and it seemed like a natural evolution. In addition, if you look at most of the projects out there to do this sort of thing, they're very specific to some cloud management system or to other components, and we wanted something that would work with a variety of CMSs and be extensible in addition.
All right. So what is OVN? If we look at it from the feature list, the overview, this is what it is. So as has been talked about, this is it's an open source L2 and L3 network virtualization implementation for Open vSwitch. So what that means is it exposes these concepts such as logical switches and logical routers to build your logical topology. It also has L2 through L4 ACLs. And so when we talk about, if we talk about OpenStack, OpenStack has this concept of security groups that's defining your security policy, and OVN has a really nice implementation of what's needed to provide that. It actually is even more powerful than what OpenStack needs, but that's something that's included. It builds overlays, and for the overlays between your hypervisors, it uses either Genev or STT. OVN also uses VXLAN. Right now that's limited to talking to VTEP gateways, which would be the top of rack based or software based logical and physical gateways. That would be switches that implement the hardware VTEP schema. So OVN works everywhere that OVS works. It's included with OVS. It's in the OVS Git tree. Most of the development has been on Linux, either with the KVM or Xen hypervisor. It's also been developed with Docker quite heavily as well. DPDK is mentioned here. It's interesting to note, actually, the way OVN works is actually transparent to whether you're using DPDK for the data path for OVS or not. That actually doesn't matter to OVN. So that works. There's been discussions about extending OVN to make it work on Hyper-V. It doesn't work there today, but there seems to be a lot of interest there. As far as what OVN is integrated with, Ben mentioned that the intention here is to build something that's agnostic to what the underlying platform is. So to work with multiple cloud management systems. We've been developing integration with OpenStack Neutron basically in parallel with OVN itself, so that integration exists. There's also some integration with Docker's lib network. I think that work was actually just merged into the OVS tree just this past week. And then, but it could be integrated elsewhere as well.
There's some work on Kubernetes, for example.
So just to get into some of the particulars of the project. So it's being developed, obviously, by the same community as Open vSwitch. So all of the development is occurring on the public mailing list. All the discussions about the project are happening in public on the mailing lists and in the IRC channels. It's vendor neutral, as you can tell. Russell is from Red Hat. We're from VMware. There's a number of other contributors from HP and Intel and other companies as well, all contributing to the OVN project. As mentioned, the design and implementation are all occurring in public, and we're developing it under an Apache license, just like the Open vSwitch user space components, which makes it a bit easier in a lot of organizations to deploy it, because some organizations are concerned about like GPL licensing, and so you can make modifications. You can bring OVN in-house and make your own modifications to it, and you don't have to share them with the community. So the goals of the project, obviously we want it to be production quality. It's just like the OVS project. We're taking that very seriously. I think OVS has a good reputation for stability and kind of an eye on performance. The design, we're trying to make it very straightforward. We've seen a lot of other implementations where people try to use OVS and they end up not doing things as cleanly as they could have. And Chris sort of touched on this with the OVS plugin that exists for Neutron today. So the initial goal is that it should scale to at least thousands of hypervisors, and then each one of those hypervisors should be able to support many VMs. And then we want to have improved performance and stability over the existing OpenStack OVS plugin. That plugin that Chris was mentioning before was not actually developed by any of the OVS developers themselves. It was done by the Neutron developers, and as Chris mentioned, is not the design that we would have chosen to implement it. And I had been forwarded that same Etherpad that Chris was talking about that was all of these criticisms of OVS, and I looked through it, and really all of the criticisms were around the plugin, not around OVS itself. The one criticism around OVS was that it's really complicated, which that is true. But and that's one of the things that we actually hope to improve with OVN is the documentation around using OVN. It's a little easier for us to document something like a product, like product's not quite the right word, but a project like OVN, which is intended for end users, where OVS itself is very flexible. It's more like a programming language, and so when people ask for help, it's very dependent on how it's being used, and so. We're hoping to have better debugging tools and better documentation around OVN, or at least more documentation that's helpful for end users.
So I'll say a few words about how the OVN implementation is structured. So most systems that implement network virtualization have some sort of a central controller. And so at the top of the picture is where you would normally see that. But you'll see that, in fact, what we have there is a pair of databases. And in fact, most of OVN is coordinated through these databases. The southbound database there is what all of the hypervisors that participate in an OVN domain actually talk to. So on each of the hypervisors, we run what we call a local controller, OVN controller. That talks to the local OVS through OVSDB and OpenFlow, and it talks northbound to this central database. The central database is also managed by what's closest in the system to a central controller, a daemon called OVN North-D. OVN North-D is it sort of does mediation with the CMS plugin. Its goal is to take the instructions given to it for the logical shape of the system and translate those into the form understood by the local controllers. So, like I said, the configuration of the system is coordinated through these databases. The bits that are sent down to the local controllers on each hypervisor are primarily in the form of what we call logical flows. These are a lot like OpenFlow flows, except that they talk about logical entities like logical ports and logical routers and don't refer to the physical structure of the system at all. So that local controller on each system converts between this logical representation and the physical structure of the system. In this way, the desired state of the system can be clearly separated from the actual physical structure and runtime state of the system. We've found so far that this architecture is clean and makes it easy to maintain and to understand the system.
Okay, so let's talk about OpenStack security groups again. This is something that Chris mentioned before. This is something that's important to OpenStack. Wasn't necessarily the easiest thing to do with OVS historically. And so this diagram shows how OpenStack has historically implemented security groups, and well, still does today. And to do what's needed there, so for every VM, it has to create a separate Linux bridge and an extra vEth pair, and it uses IP tables to implement security groups. So that's, this is just basically cobbling together what was available to get to implement what was needed. Luckily, we have a new way we can do this. This is not how we do it in OVN. We use the new integration with the kernel's connection tracker that is just recently merged into both the kernel and OVS itself. And so with this way, we get rid of these extra layers. It's a whole lot simpler, and it turns out to be much faster. And there's a link at the bottom of this slide. This is a blog post that I did a few weeks ago that talks about how we implement security groups with OVN, but then it also talks about how then OVN implements its ACLs using the contract integration. And then there was a presentation at the OpenStack Summit in Vancouver roughly 6 months ago that presented the contract integration. It did some presentation of some performance numbers, and the performance benefit was quite significant. So if you want to dig into that, I'd encourage you to go check out that presentation. And I believe there's more discussion of that integration at the conference as well. So I'll leave it at that.
So I'll just very briefly describe how we're handling L3 logical routers in OVN. The way it works is not at all like the way it's happened in, for example, the OVS plugin for Neutron. We actually implement routing through logical flows in a completely distributed fashion. So any hypervisor on which a packet is sent through a logical router implements the routing at that hypervisor, and it merely tunnels the packet to the hypervisors that should receive the packet. We have an implementation of ARP and neighbor discovery suppression so that if IP to MAC bindings are statically known, then ARP traffic never crosses the physical network. We're also able to take better advantage of flow caching in this architecture. Without OVN, each packet could potentially pass through multiple routing layers and incur multiple expensive packet classifications. But with OVN, the cache does everything in one step, and which improves performance significantly, especially if there are multiple logical routers. We don't use the Neutron logical L3 agent.
And I just wanted to mention one other thing. In the presentation, there's a lot of mention about Neutron. Part of that is because these are slides that were based on a talk we did in Tokyo at the OpenStack conference. But OVN, while we're working very closely in the OpenStack community, is not tied to Neutron or to OpenStack. And so you can use command line utilities. We're talking with other people like Open Daylight about possibly integrating Oven as well. So just wanted to make the point that it's not all focused on Neutron. So then wanted to get into the gateways, how traffic goes from logical to physical space. The way we're doing that is with what we call the VTEP OVSDB schema. This is something that we upstreamed probably about over a year ago into OVS that allows us to describe these logical to physical mappings in hardware. And so, as you can see here, there are a number of hardware vendors that have actually implemented this schema. And so that allows OVN to control these switches and map the logical physical mapping so that you can take physical workloads and bring those into your logical network. And so we use those both for if you have servers that are sitting off, or if you also had if you were sort of your north-south getting traffic in and out of your data center, we're using this VTEP schema. So we are using the VTEP schema for the hardware, but we're also using it for software as well. So we have a DPDK-based implementation that will allow us to use OVS with DPDK to get traffic in and out as a software gateway. We are currently the capabilities of VTEP are somewhat limited to L2 and L3, but we imagine having to either extend that or maybe move beyond the VTEP schema to start adding additional stateful services and failover. So here's a diagram that just shows using OVN to integrate the physical workloads. So you have in green here the Oven cluster. Those are the central databases and the Oven North D, and then it's communicating with the various hypervisors, just as you would, as been described. But then it also now is speaking to the VTEP, the top of rack, using this VTEP schema over OVSDB, and then you can see that you have the physical workloads that are now being brought into the logical environment. And this is something that we've actually tested. Brocade has this working. It should work actually with any of those vendors I had on the previous slide. But we've done some integration with Brocade, so we know it works with their switches. And we're looking actually at starting to add L3 and ACL support to the VTEPs as well, both the emulator and with starting to work with the hardware vendors on that.
All right, so I wanted to mention upgrades a bit. So when you get into this larger scale environment, a distributed environment, how you upgrade the distributed environment is a big concern. It's certainly a concern near and dear to OpenStack operators' hearts. So I kind of wanted to mention that this is something we've been thinking about from the beginning and making sure that we have a good plan for this. And so, I mean, effectively, the way this works is the database schemas that we have are versioned. The changes that we'll make to the schema going forward once we move into a more of a production stage of the OVN project is we'll make sure the changes that we make to the schema are backwards compatible, and that allows rolling upgrades. The process effectively mirrors the way that rolling upgrades typically work in OpenStack. Again, this isn't specific to OpenStack, but I come from the OpenStack world, so I think about that. Think about it from that angle a lot. But you typically upgrade the central control plane first. That would be for OVN, that's upgrading the central OVN databases, and then you can roll through and upgrade all of the OVN controllers along the way. And one thing interesting to note is this is effectively the same strategy OVS has been following to be a friendly project to the other projects that are consuming it. The Open vSwitch schema, they've been very careful to make sure that the changes there are backwards compatible. So I think we have a good plan for how this is going to work.
So just to mention some of the work that's coming up soon, we're already working on network address translation so that OVN can talk to the outside world, and patches have already been posted related to that. There's a couple of groups are working on some native DHCP support so that the Neutron DHCP agents wouldn't be necessary. There's been some design work on service function chaining, and that's still in progress. Feel free to join the discussion if you like on the OVS development mailing list. And there also is some work on basic load balancing, which is required for Kubernetes integration, which is also in progress. There's some resources if you're interested in trying it out or getting involved in development here. And if you want to help, please feel free to try it and test it. It's being developed in the same place as the rest of Open vSwitch, so you can join us on the development mailing list or in the IRC channel. There's a weekly IRC meeting in the hash Open vSwitch channel at 10:15 Thursdays Pacific time.
Yeah, and if anyone happens to be interested in the Neutron plugin, the Neutron plugin for OVN is developed just like the rest of OpenStack. We have a Git repo over there, and we use the same resources as the rest of OpenStack development for discussion. The OpenStack dev mailing list, and then we have a OpenStack Neutron OVN IRC channel on Freenode where people working that plugin discuss as well.
And feel free to talk to any of us about it if you run into us at the conference.